Hey everyone, this video is to help you with adding rational expressions when we don't have common denominators. So it's going to be a little bit different. The first step that we're going to do is we are going to factor the denominator. More specifically, only the denominator. You want to leave the numerator alone. From there, we're going to determine the least common denominator, the LCD. The LCD is going to be the smallest term or terms that every single denominator can divide into. The third step is we're going to multiply each fraction to get common denominators. We're going to add them like we normally do. From there, we're going to simplify. And don't forget the excluded values. So a little bit different than what we've seen before. The last process is going to be the same as the previous video. Only difference is we want to make sure we don't forget or we get the LCD first. So when looking at this first example, 4a over a squared plus 20a over 8a. A squared and 8a are both monomials, which means our LCD is going to be a monomial as well. So the first thing that I like to look for with my LCD is I like to think about the coefficients. So the coefficients that go into each of these, you don't see one in front of a squared. That means there's a 1 and we have an 8. Well, the smallest number that both 1 and 8 divide into is going to be 8. Then we want to think about our powers of a. I have an a and an a squared, which remember is a times a. That means my LCD also has to include an a squared. The reason why it has to be the squared is because if it was just a, this a squared would not be able to divide into it. So we want to make sure that it's whatever anything can be divided into. And what we can always do for a quick little check is take my LCD and make sure that each of the denominators will divide into it. And the other cool thing about this is whatever you get for the result when you do this is what you need to multiply both of the fractions by. So if I look here, my a squareds are going to cancel out. You're left with a. That means the fraction on the left, both numerator and denominator need to be multiplied by 8 to get an LCD. On the right here, the 8s are going to cancel. This a will cancel with one of these a's. That means the second fraction has to be multiplied by a over a. And then remember, when we do this, you're really just multiplying by 1 because you have the same thing in numerator and denominator. So in my first fraction, 8 times 4a is going to give me 32 a over 8a squared. Plus, and then my second fraction is going to give me 20a squared over 8a squared. I see a lot of people that will make a mistake right at this point of trying to cancel things out from the numerator and the denominator. Remember, you don't eliminate until the very end. So from here, we're going to add. So in the numerator, I'm going to have 20a squared. I write this one first because it's my bigger term. I have the bigger exponent plus 32a over 8a squared. And now I treat it like any other simplifying problem. So in the numerator, I try to factor it. The first thing I look for when I factor is a GCF. I have a GCF of 4a. What we're left with is 5a plus 8 over 8a squared. And from here, I can eliminate. So The 4 becomes a 1, the 8 becomes a 2. This A cancels with one of the A's. Your final answer should be 5A plus 8 over 2A. Yes, we've eliminated an A, which would be an excluded value of 0, but because we still see it in the denominator, we don't worry about it. Example 2 makes it a little bit different. We want to make sure that we factor on the right so we can figure out exactly what our LCD should be. So I'm going to rewrite my first fraction. 7 over y plus 8 plus, and then my second fraction, the two numbers that multiply to 24 and add to 11 are 8 and 3. So when determining the LCD, the fraction on the left has a y plus 8. That means my LCD has to have a y plus 8. The fraction on the right has the y plus 8, so I don't worry about that. It also has a y plus 3, so my LCD better have a y plus 3. And then like we did previously, we're going to check both of them. So if I take this LCD and I go through and I divide it by the fraction on the left, the y plus 8, these would eliminate, and you'd be left with y plus 3. That's what you're supposed to multiply by. Now, if I were to take the fraction on the right, y plus 8 over y plus 3, everything's going to eliminate, which means you don't have to multiply the second fraction by anything. Technically, you could multiply it by 1, but it would be unnecessary work. So in the fraction on the left, that's going to give me 7y plus 21. I'm going to keep the denominator factored because I know I'm going to factor it eventually, so why waste the time foiling it out? Now that I have common denominators, I can go ahead and add. And notice that what I did at this stage is I went ahead and I foiled these together because you're going to want to combine terms, so you always want to factor the numerator at the very end. So when I add these together, I'm going to get 7y plus 56 over y plus 3 times y plus 8. And like we've done in the past, we factor where we can. There is a GCF. I can take out 7. That leaves me with y plus 8 over y plus 3 times y plus 8. And then I can eliminate my common factors. So I cross out y plus 8. I'm left with 7 over y plus 3 with an excluded value of negative 8. And for my last example, we're going to go ahead and we're going to factor b minus 5. And then the fraction on the right, the denominator, the two numbers that multiply to positive 15 and add to negative 8 would be negative 5 and negative 3. So for my LCD, the fraction on the left has a 4 out in front. This fraction has no number out in front, so I have to have a 4. I also have a b minus 5, so I need that, which is also in the second fraction. So now I move to the second denominator. It also has a b minus 3, which means my LCD better include a b minus 3. Now what we've done in the past is divided to figure out what you need to multiply by. You can also just look at it at this stage. If you look at this first denominator, 4 and b minus 5, 4 and b minus 5. That means what it's missing is the b minus 3. So I multiply numerator and denominator by b minus 3. When I look at the second fraction, it has the b minus 5 and the b minus 3. It's missing the 4, so I multiply by 4 over 4. So when I do this, I'm going to get 2b minus 6. Remember, you want to keep the denominator factored, but you want to make sure you distribute in the numerator, and then 4b minus 24. And then once they're common, you can combine everything. So in the numerator, 2b and 4b is going to give me 6b. Negative 6 and negative 24 is negative 30. All over 4 times b minus 5 times b minus 3. I factor out a GCF of 6 in my numerator. So you're left with 6 times b minus 5 over 4 times b minus 5 times b minus 3. And then final step that we do is we cross out what we can and we list our excluded values. So the b minus 5's eliminate. You also have a 6 over 4. That can reduce to 3 over 2. So your final answer is 3 over 2 times b minus 3. Remember, just leave it in its factored form with an excluded value of 5, because 5 minus 5 would give you 0 in the denominator.